Hi everybody, sorry for the short delay. So welcome to Fyuz 2023, and thanks for joining the IP transport workstreams breakout session. My name is Erdem Çavuşoğlu, and I'm working as a technical program manager at Meta, and I am supporting the OOPT project group, DOR in particular. I hope you find this day a fruitful day and enjoyed the sessions in the main stage and the other stages during the day. So today in our agenda, we are going to start with a DOR subgroup keynote will be presented by Pérez from Vodafone. And then, second, we will have a presentation from Ian Sutton from Ceragon Networks, with the state of open and disaggregated transport using DORs. Unfortunately, Rafael couldn't make it today due to the unfortunate event in Israel, so Ian is going to replace him. Thanks, Ian. After Ian's presentation, we will have a fireside chat about Vodafone and Telefónica's, let's say, disaggregation journey and future plans. And we will have Jose Antonio Gomez and Rafael Canto Palancar. Up next, we'll look into the details of the hot topic of the year, AI and AI networking, from, let's say, DriveNets and EdgeCore. So Juan Rodriguez Martinez is going to present the DriveNets presentation, and then we'll have Heimdal Seao and Nanda Ravindran from EdgeCore. And last but not least, we'll have a panel discussion, which will be a kind of mind-opening session about the new DOR initiatives like DDBR-PE and DIR. So we will have Diego Marimaraton as the moderator of the panel. Then we will have Paul Gunning from BT. We'll have Rai Chang from UFSpace and Abhijit Prabhun from IP Infusion. So due to the high number of sessions today and the, let's say, as this is the last session of the day, we may, let's say, exceed the duration for like 5 to 10 minutes. My apologies for that. And yeah, so without further ado, I think we can start. Please welcome Jose Angel Pérez.
Thank you, Erde. Good afternoon, everyone. I'm Jose Angel Pérez, a principal engineer at Vodafone. I work in the transport product unit, the team in Vodafone that's in charge of driving the network strategy, defining the architecture, and selecting the global vendors in the IP and SDN area. I joined the TIC community for some years now, so contributing to the disaggregated open routers, and I've been able to be part from inside in order to, in this amazing journey about how open and disaggregated networks are transforming the network landscape. This presentation today is trying to provide you with the latest news in the DOR subgroup. We are also trying to cover the latest deployments, also the latest news that the ribbons and the different vendors, as well as finally we are trying to cover what is coming next in order to see beyond what we are carrying down. So before going to detail of the disaggregated open routers, we try to see the definition of the subgroup. What is DOR? DOR is defining the open and disaggregated router for what? For a core provider, for a provider edge, for aggregation, internet, and set-side gateway. Now, as we can see in the slide, since last May, the disaggregated set-side gateway and the disaggregated open router subgroup were merged into the same disaggregated open routers subgroup. In order to coordinate in the different force and the different resourcing in a more structured and efficient way. So the disaggregated set-side gateway and also the DDBR that we see later more in the day will still continue as board string. And a new one, the DAR, will be created in the next year, in the 2024. We are going to see it later. All this is reflecting in the new structure of the DOR. As you can see, the DOR is under the Open, Optical, and Packet Transport group. And the DOR is led by Eva Rossi, that is here, from Vodafone, Kenji Kumaki from DDI, and Diego Mari from Meta. As previously mentioned, the DOR is divided into the DCSE, DDBR, and the new DDR. Now, we are going to talk about how the different initiatives are going to fill the gaps and contribute to cover the full routers portfolio. Starting for the disaggregated cell-side gateway, this is a widely adopted solution to provide connectivity at the very edge of a network. Next should be the disaggregated and distributed backbone routers. In this case, should be for core providers and internet gateway. This is a solution based on a really innovative way and also try to use efficient capacity scale out. The next one should be the DDBR for provider edge. This is try to complete the full IP portfolio together with the internet gateway and the core provider. And finally, this is new from this time, it should be the disaggregated aggregation router, the DAR. This initiative will be created in the 2024, in next year, and the expectation is to fill the gap between the access and the core. So from here, we like also for sure for the DOR subgroup and for the new DAR work stream, we invite you to join the team to bring these new routers to life by working together. Now, we can tell you the two major documents that were on releases this year. The one should be the detail, the technical documents for the provider edge that was releasing in May. The rest one was the detail of the TRD that was released for the disaggregated cell-side gateway, which should be like the second release. And CQO, the next document, we are planning to release the detailed TRD for the provider edge router that's expected to be very soon. So the expectation is even during this month, we can able to make the release of this new document. And the next one should be the ones related to the test plan documents. There will be one for the disaggregated cell-side gateway, another one for the DDBR. Regarding request for proposal, we can say that it can be highlighting one related to the internet gateway, that is an ongoing process in Turcell, and some others like related to the disaggregated cell-side gateway. For instance, we have some examples, some ongoing process also in NTM. Now, regarding ribbons and budgets, we would like to congratulate EdgeCore on the work done over the last year, resulting, as you can see, in no more, no less than 6 bronze budgets. These are for requirements comprising in both in DDBR and also in DCSG. Also, an additional silver one is related to the testing of one of the solutions for the DCSG. So, well done to them. Now, this is a wordmark, it's a visible proof of the impact of the DDBR and also DCSG trials and deployment over the last year across the different operators. The DCSG continues its impressive expansion with new commercial deployments, as you can see, in NTN, in Vodafone, in Spectra, in Telcom Group, and also in Africell. On the other hand, on the DDBR side, it has just started the introduction and deployment of this type of solution. Two examples of them is Turcell and also KDDI, and also the testing that is ongoing in BT operator. As last part of the presentation, we are going to provide you, or we look at what is coming next. We're starting with the DDR for the provider internet gateway. So, as you can see, this has gained momentum with the participation of 8 different operators, as you can see at the bottom of the slide. The next step should be the evaluation of the different vendor solutions to get the testing ribbons or testing budget that we're expected to have, thinking about the silver and the golden one, starting from the end of each year. Now we have the DDR for the provider edge. We complete the technical requirements document in last mile. We are going to release the detailed one in very short, expecting in October, and thanks to the support and contribution from an increased number of operators, being Liberty Global, the last one to join. As you can see, the expectation is that to release in short the DTRD, and the expectation is to have probably at the end of this year, beginning of this one, how should be the result of this vendor analysis. And finally, we have the DSG. The DSG has just released the detailed technical requirement document from the second version that's where the vendor evaluation is ongoing, expected to have also the result of this analysis at the end of this year. So what can be gleaned for this presentation? So probably we need to have in mind three main points. The first one, the Disaggregated Disaggregated is continuous its impressive expansion across the different operators. The second, the introduction of the DDBR has already started with very promising results. And finally, with the DDBR for the provider edge and also the new disaggregated aggregation router initiative will complete the full landscape of the DOR. So, and all of this under the same and new DOR structure, and thanks to the support and contribution of increased number of operators and companies in which you all can collaborate. So that's all from my part. I don't know if there's any question. Thank you.
Thanks, Jose. And up next, please welcome Ian Sutton.
Thank you. Oh, let me go back one. So my name is Ian Sutton. I'm standing in for my colleague Pérez, who was due to come here, unfortunately, due to events in Israel over the weekend, as well as some of my other speaking colleagues that we had to jump in at the last minute. So wishing them well. I'm here to present Pérez's slides. We're talking about, it's a survey and the results of it on the state of disaggregated transport. So I shall proceed. If anyone wants to heckle and make things easier, please feel free. So Ceragon, how many people in the audience have ever heard of Ceragon? Wow, this is good. Well, my boss has as well, that's great. So we're a global company. We've been around for about 20 years. Our specialism has been historically in transporting high bandwidth radio communications for the RAN transport. And we turn over around 300 million every year. So what we see and what everyone in this room is familiar with is the events that 5G is bringing. It's bringing the start of an exponential curve up in terms of traffic, in terms of the cell sites, subscribers, everything in the network. So the complexity is going upwards for sure. And I'll go forwards instead of backwards. There we go. Sorry about this. Okay. So what it means is we're going to have more hardware, more cell sites in the network. We're going to have more aggregation routers, more high-capacity links, a lot more complication. And what we need to do is we need to simplify this as well. So there's a conundrum there. So we did a survey in partnership with Fierce Wireless and Tantra Analyst. We're looking at the general market awareness of DORs, okay? What the relevant people in the market thought about the acceptance, the stages of evaluation and deployments ongoing at the moment, early lessons learned during early deployments. So what have we found out already? How can we improve? And plans for adoption of DORS in the general network. So it was quite a comprehensive survey, global survey, 30% of feedback from the States, 70% from the rest of the world. From 500 participants, about 60% of those were of what we call from relevant companies, and a very high executive involvement as well. So this gives us a good picture of where we're going. Around 20% currently planning to deploy or in the process of deployment, so a good percentage of deployment. What did we learn? 70% of the users that were polled were aware of the technology, so that's a good start for the adoption. And 60% of that 70% were actively either evaluating or about to deploy DORS as well in their network. I believe this survey should be issued on our blog in the next 1 or 2 days, so everybody will be able to download it and look into the greater details at their own requirement. So what are the reasons for considering a DOR? Okay, obviously reduce CapEx to make, to hopefully avoid the vendor lock-in, to pull more people into the ecosystem, and using Metcalfe's law, obviously bring down the overall cost by upping the number of participants. Flexibility, obviously being able to mix and match the hardware and software. You've seen there's a lot of great vendors who are fully embracing this, the mix of the new ecosystem here. And eventually for the service providers, it will allow them to roll out more services quicker, generate faster revenue streams as well. The challenges that we received in terms of feedback, okay, the number one was the product maturity. It's early days. We're at the start of the S-curve of adoption at the moment. So this is something that we're obviously focusing on. We have some nice lessons learned from some early deployments ourselves. Obviously, existing interoperability with the networks that are currently deployed. We're not going to go in and replace everything at once, so we have to consider innovative ways to make the coexistence for the transition period a lot easier. And obviously quality and reliability. We need a track record, so we need to have more deployments going out as well. And I've got a nice case study that I'll share with you at the end of this presentation, just to show you how things are moving. Most of the participants told us 53%, well, over 50%, they envisaged that the rollout was going to happen at the edge of the network, so from the edge moving inwards. A surprising amount, we're also talking about aggregation as well for adoption of DORS. So there is a significant market opportunity there, and the adoption with our DCSG offering is becoming quite interesting. So the way that Ceragon have approached it, we obviously have the basis of the open hardware platform. So we have our own products that we've self-designed, and then when we need to scale up in terms of port density and switching routing capability, then we use commercial off-the-shelf products from some of the vendors you can see here today as well. On top of that bare metal hardware, we also have the IP and Fusion network operating system, which provides us a rich and diverse range of features to offer to our customers as well. But we're a radio vendor as well. So we had to think of an innovative way to lock this to our radio ecosystem as well. So what our incredible R&D guys in Israel came up with is a way of virtualizing the indoor unit function. So traditionally this was an extra box. So they've stamped it down and they've locked up our IP in a software Docker that sits alongside the network operating system on top of the hardware of the bare metal server, and it's acting as a virtual indoor unit. So it's handling all of the IP address management, it's handling the carrier aggregation of multiple radio carriers as well. It provides fast and remote provisioning, and we've got some really interesting presentations about AI later on, so we're hoping that we can multiplex in with that as well. So what it looks like today, if a customer wants to have layer 3 out in his network, He's operating a network of split mount radio systems. So this is a radio function indoor unit, lots of connected outdoor units. And then he has to put an extra cell site router on site. This has been the history for the last probably 10, 15 years. So now what we're doing is we're allowing you to consolidate all of that in one physical hardware. So that's less space in the cell site, less power dissipation, less heat to manage as well. Virtualizing that software function, so it makes your rollout of more cell sites and a greater depth of coverage a lot easier. Okay, another way of visualizing it. Okay, so we've turned what would be normally 2 indoor units, one for layer 3 and one for layer 2, and we put it all into one. Okay, so this is a case study I was talking about. So this was a greenfield deployment on Bermuda. The operator who was rolling out 4G and 5G, full Open RAN system. And we had to plan with a limited amount of radio spectrum for hauling, so we created a nice, you can see a figure of 8 around there. The core site, which is the one with the red ring around it, that obviously we have to transport all of the huge capacity from the core to the center of the figure of 8 to distribute it. So we overlaid several radio links. We bond together the capacity to give about 25 gigabits worth of capacity. And around the rings, you can't see it, but it's about 2.5 gigabits around the rings as well. All of the sites have a DCSG, one of our IP50FX routers there, and it's connected to the 4G DU, the 5G DU, and the east and west radio links as well. So this has gone very well. It took about all of 22 to plan, and it's just finished rolling out in 23. Mission accomplished. Okay, and I'll just leave you with a quote from the CTO there and some nice pictures if anybody wants to go and do a site survey in Bermuda. It's a nice place to visit. Any questions? Feel free, come and see us. We're on booth number 5 as well. We've got the regional president here, Marian, the expert of our routers. Thanks for your attention. Any questions? Anyone want to throw anything at me? Thank you very much.
Thanks, Jane. And up next, please welcome Jose Antonio Gomez and Rafael Canto Palancar for the Fireside chat.
Hi, good afternoon, everyone. My name is Jose Antonio Gomez. I work in the network architecture team in what is called the transport product unit, mostly responsible for all things optical and SDN, and also working a little bit on the IP disaggregation space.
Hello. Hello, everyone. Pleasure to be here with you all. I'm Rafael Canto. I'm head of innovation in the transport and IP area in Telefónica CTIO, and one of the projects that we are following is the Disaggregated open routers. First of all, Jose, I would like to start asking you a question. So when you look back and you look to the efforts that you've done as an operator to drive disaggregation, open IP disaggregation, and its adoption, what do you see?
Well, I'm going to speak mostly from the perspective of the DCSG, no? Which is where I have been working the most, and it's probably one of the most mature projects. When we launched the idea of doing the DCSG back in 2018, somehow we thought that we were a little bit alone. No, it was probably the first attempt at doing disaggregation in an IP router. And okay, we came to TIP, we made the proposal. And the funny thing is that we suddenly realized that there was an incredible traction. Now, many other operators were interested, like you guys, and quickly joined the effort. So it was a little bit of a surprise, no? But it facilitated, let's say, the takeoff of the project, and let's say delivering a set of requirements that was common, and engaging with the vendors, no, with a single direction. Okay, it doesn't mean that let's say all the requirements are the same. There are things that that are somehow different from every operator, but it facilitated a lot of work. No? In Vodafone, it was clear to us that, let's say, disaggregation was somehow a different way of doing things, and that we have to prove it and to demonstrate it, not only to the market, but also internally. No? So let's say we did a lot of work together in testing and validating hardware and software combinations as they were becoming available in TIP community labs, no, for instance. And then on our side, internally, we did also a lab and live network trials to demonstrate that the DCSG was working as part of a network. No, we tested with our hardware and software, with our backhaul and radios, with the configurations that we use in our network, with our use cases for mobile traffic, for enterprise traffic, etc. No? So this was a big effort, but it was worth the effort. No? Why we started with DCSG? We started with DCSG because at the end, we were in a moment that we were about to start the 5G deployments, and we had to perform upgrades of the Telcel routers because maybe they were not didn't have enough capacity and so on. This was one thing. The other thing was that the capability set that we needed for the mobile backhauling was a little bit simpler than the, let's say, as if you compare it to a provider edge router. No? So let's say these were two of the reasons why we started with the DCSG and not with other areas. But the journey goes on, and we have now DOR, the DDBR, and other areas that where we are developing together in the community the disaggregation. But Rafa, what about you guys? I'm not going to be the only one talking here.
Okay, but you said many things already. So I absolutely agree with the things that you said. So for us, it was really, we were coming from the conviction that we need something open. We were coming from the initial stages of NFV, in which it was the first disaggregation that we made, but for a router, we thought we need something more. We need an ASIC, we need a lot of ports. x86 was not enough, it's good, and we need it there, but we need something different. So it was really reassuring to see that there were other guys like you and the rest of the participants that they were in that same journey. So also it was really reassuring that we were able to discuss and in the community and to really set up a group of use cases, common use cases, with common requirements, agreed requirements that we were able to put there. For sure, there will be, let's not be naive, there will be some particular things that we need for every different operator, even every deployment of the same operator. But there's a good set of good starting point in there. So I believe that we've come from the initial reluctance for when we discuss with other CSPs or with other even within in Telefónica within our operations about the initial reluctance to the conviction that these are technically very valuable technologies that have matured very quickly, and they can compete in our processes to be deployed as a product. For us, this has been key. TIP has been key for us as an ideation community to create the product, to discuss with you, to see what we really needed, to prioritize use cases, to define those requirements. Also, because the collaborative work that we've made, testing, many hours in the lab, talking to you and to the rest of the suppliers and also to the rest of the participant operators, it has helped a lot. And I think that this is the right way to go, and it shows us that we can do many things if we do them together. So, and the important thing here is this is not only for the participants of the PG, but also for other operators that are willing to test the solutions or to deploy the solutions. They have the TIP marketplace in which all those solutions are listed with their badges, and they can really ensure that they are mature enough to be deployed. Also, finally, it's very important that I think that it's very important that it served us to establish the market opportunity for that industry that needed to work with us, and to see that there are many operators that are willing to have this kind of solution. So, Jose, I talked also a lot. So what about you? What do you see about the community approach of TIP in developing open and disaggregated solutions?
Yeah, well, first of all, for me, it's I would say my experience is that it's a good place to, let's say, share ideas and discuss ideas, and finding common ground on those ideas, on the requirements, use cases, scenarios, and so on. So in my perspective, this has been a very let's say, valuable asset. Okay, it has also helped a lot with let's say, resources. It has facilitated building and using community labs, and it has facilitated as well the engagement with new entrants in the market. Now, for my experience is that there are a lot of, let's say, commonalities in terms of, as I said, requirements, scenarios, and so on between the use cases in different operators. And let's say agreeing on those and building things like the detailed technical requirements documents and publishing them, let's say, gives a clear direction to the vendors in the ecosystem, okay, and those that could be potentially interested in developing solutions. It gives them a clear, let's say, guidance and direction. No, before I would say in many cases, they didn't even know with who to talk, and thanks to somehow to TIP, they can see the opportunity, they can see, let's say, which are the contacts, which are the requirements of the product that they need to develop, and I mean, for me, this is really valuable. And then, as I said before, I mean, it has been providing the resources, the TIP community labs, etc. Okay. With regards, let's say, the integration of some of the challenges that we have faced is that, for instance, how to integrate the DCSG in our networks. Now, for us, it was fundamental to show, let's say, to the technical community inside Vodafone that the DCSG was feasible. And as I said before, it was fundamental to perform the lab tests and live network trials, things like trials that we have done in South Africa or in Romania. They come to my mind now. So it's important that, let's say, you see that the DCSG or any other type of disaggregated solution works in a real scenario, no, with real configurations that are the ones that you usually use in the network, right? Radios, backhaul, okay? So this is one fundamental aspect. The other major aspect is with regards on how to integrate those solutions in the network, no? And I think with these trials, we have also achieved, let's say, a knowledge on how to, let's say, and we have, let's say, seen how to let's say, tackle that, no, how to address the integration effort. I think now the technical teams in Vodafone understand what it means to use disaggregated solutions. And one additional aspect I was forgetting is that, let's say, the management. For that, it's really important, let's say, to support the SDN APIs as we are defining them in the MAST working group. So you see, cooperation is not between operators, is not only inside the project group, but also across project groups, and this is what we have done over the years. So let's say the interworking with the rest of the solutions, the integration effort to deploy hardware and software disaggregated solutions, and also the management aspects are fundamental. Okay, but in that sense, let's say there is no difference. At the end, there is no difference like deploying any other solutions. So at the end, we are having networks that are multi-vendor. We need to have the SDN management in place. We need to integrate them as any other solution. Okay, maybe we have the difference on the integration of the hardware and the software that we can validate properly in a lab or in a field trial. Okay, so at the end, more or less, you get to a point where deploying DCSG or any other disaggregated solution is like any other traditional solutions, no? But let's not stop there. But so which are the, let's say, the challenges and the issues or the difficulties you have faced when doing deployments of disaggregated solutions in your networks, and what do you think are the areas of focus going on for the community?
Okay, so the challenges. So first of all, I think this is a complete change of paradigm. At almost every part of the product life cycle, right? So it changes the way that we procure the technology. We need to start thinking on different partners instead of a single one. There is the question of the SLAs, how to maintain the SLAs if something goes wrong, if it's the software or if it's the hardware. There was a panelist in the previous session that said we need to go from the single throat to choke to many hands to shake, right? So I think that's another. That was a good phrase for that. What I can see is what we've seen is that it's not as really we haven't found any difficulties that we wouldn't find with a traditional vendor. What we see is that, and for this, the work that TIP has done and is doing is really impressive, because all the solutions are coming pre-integrated. So we did not have to fight to make the software to be deployed correctly in the hardware, because it was coming like that off the shelf. Also, you have new opportunities like being able to use third-party optics. And for sure, this is very cost efficient for us. One of the things that needs to be taken into account is when you deploy disaggregated solutions, you find also some of the issues that you really find with any solution. So it's not easy to deploy any new vendor in the network. You mentioned the management plane and the SDN control plane. For us, in Telefónica, this is really key. We are leveraging on the master specifications, and this is an essential part of all our RFQ processes, because actually what is preventing us to have more freedom of choice is the difficulty of integrating the solutions into the network. So that's why SDN control plane is key for us. And also I need to say that also the open and disaggregated vendors are coming with SBIs, with software interfaces that they are compliant with that. So it's very easy to put them into the network. There is another aspect that is also it was mentioned before in the presentation, just from Seragon before, and it's the future pair or the product maturity. So we believe that the solutions are mature enough. They are able to compete with stacks 15 or 20 years old. And what is important is when you go to a deployment and you face something that is missing, the level of agility that they are having in the product development is really impressive. So we are very happy with this. For Telefónica, we believe that we need to provide the best network everywhere at the precise moment when it's required. Open and disaggregated solutions are, for us, it's a it's an essential way to provide supply chain protection, and also to introduce innovation and disruption in our networks. we really believe in this solution. We are working on these use cases in many areas, also in disaggregated open routers. Some examples that we can mention are DDBR, in which we have extensively tested this in our lab, and we believe it's ready to compete in our RFQ processes, and this is the path we are going to follow, because in Telefónica, they are competing in equal conditions with the traditional vendors. So they need to be competitive, and they can be. So we believe that they can be. And the other one is DCSG. And in DCSG, we've trialed and deployed the solution extensively in the network, but also we have been able to do a remote upgrade of the software. This is the promise of disaggregation. I think it's very important. We said we need to really decouple the software from the hardware. We are able to do it remotely, and we are invested in a swap of our DCSG plant involving more than 1,000 elements in our operation in Germany. And I think that this is a key, very relevant milestone in the disaggregation journey for us. But Jose, what about you? Any trials ahead? Any plans that you have in mind?
Yeah, well, I mean, we have a deployment ongoing in Turkey at the moment. As I said before, we have also done several live network trials, and also working obviously on other things. And important thing that we have been doing over the last, I would say, 3 years already, or even more, is that we have embedded the DCSG requirements and the DCSG requirements into our processes, into our standard processes. No, for instance, one of them that some vendors that are here in the room know pretty well is the networks benchmark, where we evaluate vendor solutions against those requirements. No, and this helped us to have a pretty good picture of what's going on in the market. I mean, which solutions are available and ready, the level of readiness, and the level of integration, let's say, between the hardware and the software. So this is a very relevant process for us. The other thing, as I said before, is the SDN, and you mentioned as well, the SDN API, according to what has been defined in MAST. No, we are also taking that into account into our evaluation. And we are also working together with the rest of the community in the DCSG RFI that is ongoing at the moment, and I think Jose Angel mentioned before that it's going to be completed by end of the year. This RFI, we use exactly the same technical requirement document as we use in our processes. We are completely aligned on that. This RFI is also important for us to, let's say, to scout new potential candidates in the ecosystem to be considered, no, in the next round and in our process. And as I said before, I mean, we are having this deployment in Turkey that we have it. It's already ongoing, and that's it. That's it, more or less. So I think we're done here, right? I don't know, guys, if there are any questions in the audience. I think we can take. Erden will allow us to take maximum a couple of them. So if anyone wants to speak, there is a microphone over there, I think. No questions? 1, 2, 3? Okay. If no questions, we can hand over back to Erden. Thank you very much.
Thanks, Jose and Rafa. And now, let's deep into the world of AI, and please welcome Juan Rodriguez Martinez.
Okay, thank you very much, Erden. Hello, everybody. Those of you who may be a little bit disappointed not seeing my colleague Rangel Mok here, he also had issues traveling, so I will be replacing him. My name is Juan Rodriguez. I'm working here in Europe in the sales engineering team from DriveNets. What I want to talk about a little bit today is on AI networking, okay? Connectivity solutions for AI deployments, for massive AI deployments. Before that, a little bit about DriveNet. DriveNet is a very young company, but has been, let's say, accompanying operators in this disaggregation journey for several years already. And I can tell firsthand because I was working in Telefónica not so long ago and participating on TIP from Telefónica side. What TIP has done is to provide use cases, to provide telco requirements so that disaggregated solutions can, know what to expect, can adapt to the needs from telco operators. This work is not so old, but I want to remind or let you know that it's relying on previous work done on Open Compute project. There is a definition for DDC, Distributed Disaggregated Chassis, published and open to everybody by AT&T, which defines a very robust architecture, hardware architecture to be able to support the use cases of telco. So what TIP did is just to work on top of that and provide all the requirements that we have in, hearing from Jose Angel, all the different groups, aggregation, DDBR, cell-site router. It's just translation of the requirements of the operators into this architecture. This architecture, also Ian was talking about the concern about adopters of these technologies, about maturity, right? So this architecture has been deployed, working on AT&T. They speak very openly about it. More than half of the core of AT&T's network is running over this type of solutions using DriveNet software. The idea is to show you today how we can evolve this concept of DDC, of DDBR, and also apply it to AI networking, okay? Unfortunately, or luckily, we don't have a very strict definition by somebody on what AI networking is. So what I'm going to talk about is the requirements that we are seeing from the field, not only from the big hyperscalers on the left, of course they are working on AI, but also very new companies that are appearing, talking about the metaverse, generative AI. The number of applications that we are seeing is huge, and we have not even scratched the surface, right? We don't know where this will lead us. Even telco operators that we are working with, mostly in Asia, are starting to try to understand how they can position, how they can use AI to improve the services or the cost, or to offer new experiences to their customers. And the amount of investment that we are seeing is actually huge. So all the requirements that I'm going to talk about come directly from the field. And the challenges that all these stakeholders are seeing have to do mainly with the GPU. Okay, this is the key component in AI deployments. They need to maximize the time that the GPUs are working, that are coping with workloads. Okay, any millisecond that the GPU is not doing its work, it's money that is being lost, wasted from those billions of dollars that appear in the previous slide. So what they are starting to feel is that the connectivity solutions for those GPUs are starting to fall behind. They're starting not to perform at the required scale. They're starting to affect the key KPI in AI networking, which is the job completion time, okay? If you have GPUs idle, you're losing money. Of course, some of the requirements that we are seeing are having to do with openness. They need solutions that are interoperable, that they can really choose what is the best approach for them. They need solutions that scale massively. So we are talking about thousands of ports that are interconnecting GPUs in the biggest environments for AI. So we normally say at DriveNets that the DDC or DDBR can scale practically without limit. This is putting under test on this type of environments to numbers that are unprecedented. First solution that we are building for AI networking, for AI connectivity, we're talking about 32,800 gig ports. So it's huge. From requirements come the challenges, right? To maximize the time that the GPUs are doing their work, to minimize the job completion time, what they need is a connectivity solution that is lossless. Of course, if you need to retransmit a packet, it's a packet that didn't reach its GPU, it's a packet that is not being worked with, and you need predictable behavior, okay? It's not so critical a really, really slow delay. It's more critical a slow jitter, a delay that is predictable and always within some ranges. Apart from this, well, everything that we've heard before, standard interfaces, interoperability, maturity, but the key topic is a scale with performance. Okay? So I will talk later on potential solutions that we are seeing that are being positioned for this type of applications and how we believe that DDC, DDBR can cope better than those in this type of a scenario. So going a little bit backwards, I was talking about the definition of OCP for DDC. Again, this is a very robust hardware architecture based on white boxes. In this case, using Broadcom technology, we have a leaf and a spine type of topology with the spine as the fabric nodes, with the equivalent to the line cards in the leaves, so that connectivity between each pair of white boxes is achieved on a single hop through the fabric. That architecture already solves the issue of the jitter. Every couple of ports is at the same distance, it's just one hop away, so jitter is very predictable and under control. Okay? But it's not only that, it's a matter of a scale. If you need to scale this type of solution, you just add more boxes. And if you need more line cards, just put more fabric, keep on adding white boxes. You can have as many ports interconnected on an infrastructure that, by the way, can be deployed as easily from the physical point of view as any deployment of switches in a data center, because these are small type of boxes, 1 rack unit, 2 rack units, but that behave like a single entity for management. So simplicity is also there. As I said, what TIP did is create use cases, okay? Core nodes, edge node, internet gateway, now aggregation very soon, but it's just adding the requirements from the telco point of view. It's just adding the need for openness, for scale, then the type of protocols that need to be put into these boxes to build routers. So we are talking about the segment routings, the different BGPs, ISIS, all that is put into DDBR. What we believe, and it's what we are working at, is that that very same infrastructure can also be used to interconnect GPUs in the data centers, okay? It complies with the scale. As I said, you just need to add more boxes. It complies with the simplicity. It behaves like a single entity. It complies with the avoidance of vendor lock-in. The specs are open. The idea behind the Telecom Infra project is precisely openness. And it's well proven, as I said. It's not only DDBR starting to grow. Last year we had here Turkcell announcing the field trial in their network. Very recently, KDDI also publishing or openly talking about first deployment in Japan is that it's been running on OOPT for many years already, so it's a very reliable and trustable solution. What are the alternatives, right? What is being positioned as of today? First solution I want to talk about is InfiniBand. This is extremely common in HPC environments. It definitely has the performance and the scalability, but problem is, apart from not being open and being proprietary, is not so flexible. It goes well with certain types of traffic, and the adoption curve is kind of tricky for operators. It's something that they are not used to. It's also, or typically in HPC environments, this is also not open to the internet, which is an obvious demand from AI environments, and it's yet to see how it can cope. Second type of solution is Ethernet, right? It's definitely scalable. You can throw in switches in a data center. What happens when you throw too many? Just the performance is not there in terms of jitter, delay. You have packet loss. Again, is probably not the most suitable type of application. And also, we have a chassis, okay? Chassis are very common in the financial market. They definitely have the performance. It's, everybody is used to working with chassis and router, but the scalability is just not there. It's limited by a physical chassis that doesn't allow it to scale to the numbers that we were talking about. So to close all these gaps, again, the figure that we were talking, we still have our leaf and spine type of topology. We still have the same solution, the same lossless solution, the same predictable solution, where we connect lots of GPUs with the new technology, Jericho 3 and Ramon 3. These are the scales that we are achieving, 32,000 ports of 800 gig. And as easy to deploy as switches, as easy to operate as a single router. Okay, not a network of routers. Here, if you connect 32 ports providing service to 32 GPUs, the infrastructure is still a single entity. Okay. Final slide, a few numbers here, not from us in terms of savings. This comes from hyperscalers actually testing the solution. What they have found is that they can reduce the job completion time with this type of technologies on a minimum of 10%. This is precisely the same number that typical connectivity solutions in these types of environments is assigned in terms of cost to connectivity. So if you have a solution that reduces job completion time by 10%, that means that to do the same job, you can buy 10% less GPUs. That means the connectivity solution is paid by itself, it's for free. Okay. This is what they're seeing. The good thing is that the number of changes that we have to introduce to the architecture compared to the OCP project is zero, right? Maybe we need to increase the number of functionalities that are used to interconnect the GPUs. Maybe we have to close some gaps in terms of monitoring the infrastructure, but from the physical point of view, there are zero changes compared to the original specification on OCP. If any, we can just remove some of the parts of the white boxes that are not really needed, for example, the TCAM, because these are not required in this type of environment. Okay. Finally, and again, if you need to build a solution that is as less risky as possible, this has been in the network for several years already, and we can discuss about it anytime. You'll find me around or at the booth. Welcome to discuss about it. I assume we have time for a couple of questions if somebody wants to do it. Okay, either it went really bad or really good, but in any case, thank you very much appreciated.
Thanks, Juan. And now let's hear what's EdgeCore's view on AI networking. So please welcome Heimdal Seo and Nanda Ravindran. Floor is yours.
Thank you, Erdem. Welcome, everyone. My name is Heimdal. I'm from EdgeCore Networks, and with me is Nanda. He's heading our product line in EdgeCore. And today we have an exciting product. It's the 51.2 Tera switch. It's optimized for AI. I myself have been working on disaggregated solutions with OCP and TIP for around 5 years. So I think besides open networking, the pitch I have today is open AI. So what does that actually mean? So before I go describe more about the product, I wanted to share a little bit about what's on the mind of an AI operator. What do they care about? One of the things that comes to me is you want to make sure your hardware is effectively utilized. Like DriveNet's mentioned, the equipment is expensive, not only the switch, but the cabling, and of course, the GPUs. We also need to consider cost from a power consumption point of view. So the latest generation chipsets accomplish the functionalities of old chipsets much more effectively. And besides cost, there's also time, because if we can compute these results more quickly, the hardware could be used to compute the next task, optimizing cost more effectively. Now, AI workloads are different than traditional data center workloads. For example, the flows, they are fewer. But each of these flows, they could be elephant flows, very large gigabytes of data being transmitted, and this is requiring very high bandwidth. To make matters worse, oftentimes AI clusters have thousands of GPUs, and they're transmitting information simultaneously. And this causes flooding of the links, which could cause bottlenecks if they're all going to similar destinations. And this can get very dangerous in the traditional data center fabric because it causes drops, and drops negatively impact job completion times. So we thought about these concerns and how can we address this with standard Ethernet, with a standard merchant silicon. So this led us to look at this device. We are now generally released to the market. It's available. It's a 51.2 Tera switch based on Broadcom Tomahawk 5. And something very special about this switch is we have no external PHYs or retimers. It's completely simplified to a big packet processor that's directly connected to the cage. And this reduces latency, very important, but it also reduces power consumption because there's only one large ASIC in that device. Also, price goes down, there's less complexity, as well as MTBF gets improved. Another noteworthy part about Tomahawk 5, the 51.2 Tera, this single device can accomplish the functionality of 6 prior generation devices of Tomahawk 4. So if you were to buy 6 25.6 Tera device, you can just buy one of these. So you save cost, you save power, reliability goes up, it's good for everybody. But besides the design of the hardware and the capacity of the chipset, there's additional functionality required to make AI workloads low latency, high availability, dropless. And inside the chip, there are advanced features such as congestion management, adaptive routing, load balancing. There's a feature inside the chip that's very cool. If there's a fabric link that breaks, instead of the CPU updating the routes on the software side, which takes seconds, the hardware within the chip can update the routes in 500 nanoseconds. So this really minimizes the drops, which improves job completion times. There's also ability within the switching ASIC to notify other switching ASIC of drops that are upcoming and where it's being dropped. And there's a feature to retransmit the drops very quickly, so it's a lossless fabric. In addition to the routing features, there's also telemetry. So for example, this chip has 6 built-in ARM CPUs that could transmit metadata such as the status of the queues in the chip. So if a queue is filling up, you probably don't want to send it there. It could tell you the utilization of the packet processor. It could tell you the latency of the device. And you can make a better decision how traffic is routed to be more effective. And I think one last cool feature we added on this device is timing synchronization. We took the designs we did for TIP on the DCSGs, and we added it to this data center switch. So all the network elements can be aligned with nanosecond level accuracy. So now that we have the chipset, we have the device, what's next? Our dream is to create an open AI ecosystem. And our philosophy is open is better for more people to access the technology, more people to develop and utilize how they want this technology. And we saw it with computers, servers, laptops, whatever. You guys all use it today, but there's also mobility. This has improved the access to this technology, improved the innovation speed. 5 years ago, when I started working on EdgeCore and Acton platforms, I was doing open networking, so we did open hardware, but we also extended that to developing open networking Linux, so software vendors could port on our device. But we've also added features, protocol features for packet processing, forwarding on top of Sonic, made it open source to the public to use. But if you go and purchase an AI machine today, there's really not very many vendors you could buy from. The hardware is completely locked in. The software, the protocols are proprietary. So it makes it very difficult for regular organizations or companies to utilize this technology unless you're one of the biggest corporations on the planet. So I'm going to pass it over to Nanda. He's going to talk a little bit more about the open ecosystem we're trying to do.
Yeah. So thank you, Hemdal, and good afternoon, everyone. And I'm really excited to talk about the work we have been doing at EdgeCore for the last year or so. So by the way, this switch is in our booth, so it's really impressive. So when you get a chance, please stop by and take a look. So before we talk about our open AI solution, as Heimdall mentioned, there are solutions for AI that are available out there, but they are proprietary, they are closed systems, and they are vendor locked in. And we know about hyperscalers who are trying to deploy AI systems. They do not like closed systems. They always want an open system where they can build innovations on top. And this is where at EdgeCore, we want to come in and offer an open AI solution. And what do these hyperscalers, one of the hyperscalers is actually building an accelerator by themselves. And they need an open and an unified networking infrastructure that is based on Ethernet, and that's what EdgeCore platform will do. So we have a standard Ethernet-based switch, which is open, and we have gone beyond that. We have ported our Sonic distribution on this platform, so customers now have a community-driven open NAS as a solution for AI. And just like how Sonic was very successful in the data center use case, we believe Sonic will continue to lead and be one of the successful use cases for AI, ML as well. So with a standard Ethernet-based open solution, what you get is a diversity of suppliers, be it the switch, be it the NIC, be it a NAS, there is a diversity. But that diversity, comes with some challenges. And this is where EdgeCore engineers have gone and built some tools, especially for AI. AI is not just any other Ethernet switching platform. There is a lot of tuning. There is a lot of performance benchmarking that need to happen to make a system truly AI capable. And that's what EdgeCore engineers have done. So these challenges have been overcome, and the tools have enabled us to have an improved load balancing, low latency, and better congestion management that are needed for a high performance, low job completion time AI solution. Next slide. So now we want to bring this platform to the community, to our partners, to our customers, and say we have an open AI platform that is ready for making further innovations to continue on it. We have a very leading edge design on the AI platform. I mean, come on, there are 512 100 gig SerDes on this 2RU box, and that's not something easy to do. I really appreciate our engineers who have put their thing in the last 1 year and have come up with such a platform. And this is where EdgeCore's 20+ years of design experience in building hardware has helped to come up with something that quickly and with that complexity to come to the market as one of the first open platforms to come out. Second is this platform is highly scalable. You can connect multiple of those in just 2 levels and build a very high radix, low latency AI training cluster. And you could have a flat 32 by 400 gig port configuration with just 2 levels. And that's impressive. Finally, we have a very precisely engineered, performance benchmarked AI solution that has been proved to run customers' very demanding AI workloads. And customers can utilize that without doing their own tedious customizations, optimizations, or even tuning cycles. Finally, we invite our partners. We have already reached out to many of them, and they are working with us. And we believe, there will be a working group in TIP for AI soon, and we will be part of it, driving it forward. Thank you. Any questions for us?
Any questions? Yes.
Thank you. I don't think, okay. Guys, you keep on saying it's open, and the guys from DriveNet said it's open, but it's all Broadcom under the hood. And so that's not really open, that's one vendor. Now, as well as if I buy your switch, that's one vendor. How many switches of this nature are out there? So that's question number 1, and if we have time, we'll go to question number 2. I don't want to hog the mic.
Yeah. So that was the last slide I said. Guys, we want to make it open with whatever we have, and we have come to the community now. And now it's time for us to collaborate and truly make it open, right? There should be a working group in TIP. We should talk about AI. We should invite more partners, more silicon vendors to come participate in it and make it truly open. This is a good starting point. We believe that.
So I think this is not simple to build this platform. Even other ASIC vendors besides Broadcom are still working on it, so it takes time. But at the least with these like TIP and OCP, we'll contribute the designs and work together. That's the long-term path. Yeah.
Okay, thank you.
Thank you. Any more questions? If not, we're at booth number 12. The device is shown there. Thank you so much.
Thank you.
Yep.
Thank you.
Thanks, Emdal and Nanda. And last but not least, we have the panel discussion about the new DOR initiatives. So please welcome Diego Mari-Moreton, Ray Cheng, Paul Gunning, and Abjad Prabhu.
All right. Thank you, guys. It's the last session. Keep it up. And by the way, the doors are closed, so nobody can leave. No, it's a joke. Thanks, guys, for joining. We got a pretty good overview of some of the new solutions and things that the OOPT community has been working on, from Jose Angel, Jose Antonio, and all the guys. But I want to get into the details, right? Let's get under the hook. I want to ask Ray, hey, Ray, can you give the audience a little bit more information about what the DDBR-PE solution is and what the community has been working on?
So during the practice of DDBR, core, and the Internet Gateway, we learned the open and disaggregation can actually replace the traditional proprietary equipment. And then talk about the provider edge. It requires various of capacity and also need different intelligent features to provide different application scenario in the field. And then we believe DDBR is actually the one which can provide different capacity from small standalone and also a large capacity by virtual chassis.
That's great. I remember the early days of DDBR when we were talking about PE routers, internet gateways, but we always had that vision of getting to the PE, which in theory is more complex. And it's great to see how companies like UFI Space, EdgeCore, IP Infusion, and multiple others have embraced this model. I think the community has grown a lot, and we see a lot of solutions coming to the question. We see more hardware designs, maybe most of them Broadcom-based, but a lot of hardware designs and a lot of suppliers coming into the picture. Avijit, I want to ask you the same question. What can you tell the audience about DAR? We started back in the day with things like DCSG, but we've come a long way.
Yeah, I think similarly, we learned from the DCSG and really excited to see this DAR come into play. Because I think selfishly from a software vendor perspective, this gives us an opportunity to look at it from a platform perspective and give more value tunable aspects for the service providers, because if you're providing a point solution, then it becomes hard to compete. When you're looking at it from a platform perspective across the network, across different use cases, then you get more knobs to control the value proposition for the service provider. So really excited about that.
That's great. I just sharing an anecdote. When DCSG started, Eva Rossi will probably remember, we were trying to discuss about the benefits of IP over DWDM and all that stuff, and Eva and I were in Milan, if I remember correctly, and all this story about, hey, why don't we start with the Telstar router started? So that was a long time ago, and now seeing DAR embracing all this model and taking it to aggregation and so on, it's been a great journey. Paul, obviously the next question goes to you, otherwise would be like weird having only the two guys answering the questions. Right. We see all these initiatives, DDBR-PE, DAR, and so on, coming into OOPT, right? Which is a community that has been around for a while. What's the objective? What is driving OOPT to embrace these new technologies and start to push into other areas of the transport network?
Yeah, well, I would go back to what Juan said earlier with the DriveNet solution. If you look carefully at that first or second slide where he said, this is a mature solution. AT&T have made it very mature through using OCP, using DriveNets, and using EdgeCore and also UFI Space. So it was inevitable that if they've deployed it, and I believe it's like 60 or 70% of their network now, and displaced a large proprietary vendor, that the next step is to kind of scale it down. And working with Juan in our lab, when you look at what we have in a single rack, it kind of looks like a PE. Certainly a P router is big. This is much smaller, more modest. And so you could see this fitting in very, very nicely. So really the work's been done, I suppose, with DriveNets, AT&T, and Broadcom. And now we're reaping the benefits and the rewards of it.
That's fantastic. Talking about the journey with DDBR and these new solutions coming into PE, I remember the early days talking to DriveNet, Juan, and the rest of the team, and was kind of a vision of something that back then was almost impossible to conceive in the telco industry. Now seeing players like AT&T, who is deployed these in the US, and as far as we know, the network is still up and running, it's encouraging for the rest of the industry to watch.
Yeah, it's also interesting, I suppose, if you move to the AT&T's version of the DDBR-PE, which is called XEdge, they are using a network operating system from, an interesting, I would say, vendor.
Absolutely. All right, so looking into the past, and Avijit, I'm going to start with you. What are your reflections about the status of the technology, the adoption, the maturity of things like DCSG now moving into DAR?
Yeah, so the maturity is there, right? So I think our CEO in the morning session was talking about we're signing up 100 new customers every year. What we have learned from those aspects is focusing on the use cases. So taking 1 or 2 or 3 use cases and completing them end to end. And by use cases, I mean things that can the service providers can take and turn on services that they need to deliver to their customers, right? So taking that aspect and that approach is what we are looking forward to.
Ray, on a similar way, you guys started working on DDBR since the very beginning. What's your set of reflections about the maturity of the tech, but also the adoption from operators?
Okay. I think from our point of view, in the past several years, we work with multiple operators in parallel. Although we got some positive feedback and result, but the real deployment is not as what we expected. And it is actually understandable because carrier network operation is critical. And operators will not deploy a concept until they believe this solution can replace their existing legacy one seamlessly. But I think since now the solutions, hardware and software, all the solution providers are getting mature. So this is actually a chance for DDBR-PE, especially in fact, in North America, we already work with operators to proven the P code and PE can deploy up and running for over 2 years. This is proven solution. This is not only a concept. So don't be afraid.
Yeah, absolutely. I think that's a good testimony. We also see like other deployments, like in Turkey and so on, other operators embracing this model. And as you said, right, the examples of these solutions delivering high performance, reliable connectivity at the core, which is the most challenging part of the network, they are there. So hopefully we'll see more deployments and more operators embracing this journey. But let's stop talking about the past. I want to talk about the future, and starting with you, Paul. What's your vision for these type of technologies in the upcoming years? What do you think it's right out there waiting for us?
There are two things, I think. The first one would be carbon-aware networking and reducing the power consumption of these boxes. And this is where Ray, on the one hand, can choose appropriate components in his bill of materials that are able to be moderated, that we can do energy proportionality on these different components. And also that Abhijit in turn then has the ability to exploit the APIs of those components to build it into his software stack. So energy proportionality is very important for 2030 targets for all telco operators. Second thing is, and I think Rafa sort of alluded to it earlier, and I noticed that Oscar, I think, is possibly in the back of the room, and I now see that there's definitely becoming a convergence between the work that's been done on this project, DDBR, DOR, and also what's happening in Must, specifically around that there's a convergence there. There's a convergence of the routing with the very clever optics that's coming out now, the pluggables, the 400 gig pluggables, coherent, going to 800 gigs, that Acacia talking about 1.2 terabits. I think that's going to be a very compelling proposition going forward. If you like, the DDBR is quite mature. If you like the other areas are maturing, that you've been working on Cassini, and you could imagine a kind of a son of Cassini that kind of blends some of the stuff that we're already doing for DDBR and DDBR-PE.
That's great. Similar, like I remember the early days of Cassini and people saying how combining IP and optical networks in the same layer wasn't a good idea. Now it seems to be one of the main trends in the industry. So Abhijit, I'm going to ask you the same question. What are your thoughts about the future of this type of technologies, the AR and disaggregated backbone routers and so on?
Yeah, I think to add to what Paul was saying, right? So the Cassini was a really good use case for 100 up to 200 gig. And in some geographies, that's still a really good solution. Other geographies are looking at 400 gig and beyond. So we already have platforms now that are able to combine IP and OpenZR or ZR plus optics. The other aspect that Paul mentioned was not only for transport, but on the access side, also there is a lot of innovation happening. In the Ceragon session, we heard about how you can run a container on top of a NOS to provide radio access control. There was another talk about open fixed and open broadband, where we are talking about integrating OLT functionality and disaggregating that and integrating it into an aggregation router. So a lot of very exciting innovation happening on that aspect. The key there is going to be how do we make sure that all of that is operationalized from a service provider perspective, and that can provide value to them.
Fantastic. Ray, I'm going to put some extra pressure on you, and I know you landed a few hours ago, and you're dying to get some Spanish tapas, but bear with me for a few minutes. What are your same reflections about the future of these technologies and so on?
Yeah, agree with Paul and FJ's point. So we see the trend of convergence. And also, with the mature of OpenZR Plus, 400G ZR Plus, especially the high power one, actually our customer now, they already integrate the ZR Plus with a general purpose core router and converge the optical transportation together. And the management system can actually simplify the management and then with high efficiency transportation for the entire network. This is safe power and also good for carbon disclosure.
Thanks a lot. Guys, it's been amazing sharing a stage with you. As I promised at the beginning, we kept it short and very to the point. So I guess I'm giving it back to Erdem to close us out today. Thanks all of you for joining. And if you have any questions, you know where to find these guys. They have booths all around. And Paul is very easy to find. Just look for the handsome British guy.
Thanks to our panelists, and thanks everyone for coming and listening us, and thanks to our technical support team. And see you tomorrow morning. We'll be around, and have a good one. Take care.